Check this out. We've got something really fun today. This is so amazing, math. Oh man, again?
11.4 Integration by parts. Some integrals are difficult to evaluate directly. We don't know the antiderivative of the natural log of x. Now don't get mixed up. Remember that the derivative of the natural log of x is 1 over x. But if we're trying to take the antiderivative of the natural log of x, we don't know what it is yet. So we need a different method to handle this situation. Let's start with the product rule. The product rule says if we take the derivative of two functions that are being multiplied together, we take the derivative of the first one, leave the second one alone, and then add that to the first one left alone times the derivative of the second one. Now, using that equation, we're going to integrate both sides. So on this side we integrate, and the derivative and the integral cancel each other out. And we're just left with f of x times g of x. On this side, though, we integrate this side, and if we integrate two terms that are being added, we can integrate those separately and break them apart like this. And now we rearrange it for this second term right here. Isolate the second term, so we will subtract this integral on both sides. So you see now it's over here with the f of x times g of x. Now you might be thinking that we just made things a whole lot worse. But if we use this equation that we made like a formula, we change what we're trying to integrate. So on this side, we've got f of x and g prime of x in the integral. But over here, we don't. We have something else. We've got f prime of x and g of x in the integral. And so this is a different story. We might be able to do this where we couldn't do this integral. Let's see how this will work with this example here. We need to pick one part of this integrand to be the f of x. So I'll write that over here. And one part needs to be the g prime of x. So I'll write that here. Now I like to do my derivatives going down, so that's why I wrote this one here. We're going to need a f prime of x here. And we're going to need a g of x here and here. So we'll have to take the antiderivative of that piece. Now, one part of this will be f of x. Pick the part that when you take the derivative, things don't get worse. Hopefully they get better. So in this equation, x, if we take the derivative of that, it's just 1. That's really nice. E to the power of x, that's also nice. Let's look at the other one. One of these pieces needs to be g prime of x, and we're going to take the antiderivative. So if we took the antiderivative of x, it gets more complicated. It gets x squared over 2, and that's not good. So if we try to take the antiderivative of e to the x, it's just e to the x. So that's really nice, taking that antiderivative, and if we let this part, x, be our f of x, then the derivative is very nice as well. It's just 1. It was just a coincidence that this is in the first position here, and this is in the first position. That's just a coincidence in this question. Okay, now let's use the rest of this equation and these parts here to see what this turns into. So we have an f of x, that's just x. Then we have a g of x, and we see that's e to the power of x. Then we're subtracting, and we're integrating f prime, which is just 1, so I don't need to write that. G of x, that would be e to the power of x, and a dx here to end it all. Now you see that this integral is possible. In fact, it's really easy, whereas this one wasn't. And that is the whole point of integration by parts, is to take something we can't find the antiderivative of and change it into an integral that we can. So our first term is fine. X times e to the power of x. The antiderivative of e to the power of x is just e to the power of x. And it's an indefinite integral, so we need a plus c. Now we could do a check just to see that this is in fact the correct answer. You can always take this and find the derivative of it, just to make sure that you get this integrand that you started with. So this is pretty fun, because you'll see how everything cancels out. The derivative of this, we need the product rule for, so it's just 1 times e to the power of x plus x e to the power of x minus e to the power of x. The plus c is gone. You see that the e to the power of x and the e to the power of x cancel, and we are, in fact, left with the x times e to the power of x, which is the integrand we started with. Now, this equation is very long, so most people do not write it like this. We use some substitution and simplify it. We're going to say that f of x is equal to u. We need an f prime here, so we take the derivative of both sides here to get f prime of x dx equals du. Okay. We do the same thing with g of x, make it equal to just v. Take the derivative of both sides of that. Now we can take f of x and replace it with u. We can take g prime of x dx and just replace it with a dv. And make all the rest of these substitutions and turn our integration by parts formula into this. And you can see the benefits of this. It's much shorter and easier to remember. Let's try example 2 here, and we'll use the shortened formula. We need a u and we need a dv. Now, if I take the derivative of x, I get 1, so that would be a really good candidate for u. If I put cos here as u and took the derivative, it wouldn't get any simpler. So probably it will go here. I take the antiderivative of cos, and at least it doesn't get any worse. So that's what I'll do. I'll put cos 3x here, and I'll make u just x. Take the derivative of x, it's 1. Take the antiderivative of cos, and that would have been sine 3x. There would have been a 3 coming out of the chain rule when we take the derivative of 3x, and it's not here, so I need a divided by 3, or you could write 1/3 in front of this. Now we have all the pieces, so let's break this apart into uv, uv. So that's just x times sine 3x divided by 3. Then we got minus the integral of v, this, and du, which is 1. Now, another thing to notice is that we have a dv over here in the original integral, and we never see that again. We do see the u again, and we see the v and the du. So the dv is something that you can get rid of completely, and you won't have to deal with it anymore. And that's another clue to help you determine what you should assign to be dv. Let's finish this question. So we've got x times sine 3x divided by 3 minus, take the antiderivative of sine, which is, I'll just use brackets here so we don't get our negatives mixed up, which is negative cos 3x. Now there's already a divided by 3, and there's going to be another 3 coming out of here, and I don't see it, so I'll have to make this divided by 9, and then I need a plus c. And let's just clean this part of the equation up here. X times sine 3x divided by 3. Change that to a plus. And we're good. For this one, let's decide what we want to call u and what we want to call our dv. So we take a look at the first one here. It's an x squared. If I take the derivative, it gets simpler. All right. I take the derivative of this, it doesn't get simpler. I take the antiderivative of this, at least it doesn't get any worse. So I'll make this my u so that my derivative is 2x. I'll make this my dv, so sine 3x. The antiderivative of sine 3x is, let's see, negative cos 3x, and we'll say, how about change that to a negative 1/3 in front there. Now I can break this apart. So the first part is uv, so these two here. So negative x squared over 3 cos 3x minus the integral of v du. So we'll put that in brackets, negative 1/3 cos 3x times 2x dx. Now this thing here, let's try to tidy it up a bit before we go on. So I've got negative x squared over 3 cos 3x. But this part here, I'll take the negative and the constants and put them in front of the integral, just so they're not distracting me. So I'll make this plus 2/3. And inside the integral here, I've got a cos 3x and an x. Remember, I took the 2 out already. But I can't do this one because I don't know the antiderivative of cos 3x times x. So I'm going to have to repeat the process of integration by parts again. So I need a u, and I'm going to do the x there because I know if I take the derivative, it just becomes 1. And this one will be my dv. That's cos 3x. And when I take the antiderivative of that, then I get sine 3x. And I'll use a 1/3 in front here. I know this 3 is coming out. I need to cancel it out because it doesn't show up here. Okay, so I'll just switch colors and write the first part in blue because I'm not changing that at all. And I'll write the second part in green to show just which part I was doing this with again. Now this 2/3 was just in front, so I'm going to write it there and just leave it out of this whole thing. And then the rest of this turned into uv again, so this thing here. So x times 1/3 times sine 3x minus the integral of v du, and thankfully du is just 1 here, so now this is the only thing in my integrand. So it's 1/3 sine 3x dx, and looks like I used a blue bracket there, so there, I'll close it. So this green one here is the second integration by parts that we did for this integral right here. Now we can finish this question up. So we've got negative x squared over 3 cos 3x plus, distribute in the 2/3, so 2x over 9 sine 3x minus a 2/3 times 1/3, so that would be 2/9. And the antiderivative of sine 3x is negative cos 3x over 3. And then I'm going to need a plus c here. And I'll write this out one more just so I can clean up this third term. So the first term is fine. The second term is fine. The last term, the third term, sorry, it becomes plus 2 cos 3x over 27, and then we r plus c. Let's go back to the example from the very first slide, the integral of the natural log of x, except we'll make it a definite integral because we haven't done any of those yet. Now, as we were saying before, we know the derivative of the natural log of x, and we want to make that our u value here, because then the derivative is 1 over x. But we need a dv, and there doesn't appear to be anything else in the integrand, except there is a 1. We didn't have to write it, but it's there, and we can use that 1 now as our dv. And the antiderivative of 1 is x. So this would equal uv, so x times the natural log of x. And then we're going to subtract our integral. Now remember, this is a definite integral. So we can't just leave these terms like we did with our indefinite integral. We have to evaluate them at 1 and 2. Okay, inside the integral here is du and v, so that's x times 1 over x. And those are actually going to cancel and just create a 1 as our integrand. And that's a very easy antiderivative to find. So the first part here, we'll go ahead and evaluate them at 2. So 2 times the natural log of 2 minus 1 times the natural log of 1. And minus the antiderivative of 1, which would be just x. And we need to evaluate that from 1 to 2. And no more plus c, because this is a definite integral. So 2 times the natural log of 2 minus the natural log of 1 is just 0. So 1 times 0, this term is gone. So we just need this part at the end here. So minus this evaluated at 2, which would be 2. And then maybe just so we don't mess up the negative signs, I'll use a bracket here. This would be 2 minus 1. So we'd have 2 times the natural log of 2 minus 1. For this question, it's extremely difficult to tell which we should make our u and which one we should make our dv. So if we take the derivative of e to the x, it'll just be e to the x. All right, well, that didn't get any worse. But if we take the derivative of sine x, it's just cos x, so that doesn't get any worse either. All right, what about the dv? If we take the antiderivative of e to the x, it's just e to the x. What about the antiderivative of sine x? Well, that would be negative cos x. So that doesn't get any worse either. So for this one, we'll just try something random. How about sine x? And we'll make this one e to the x. So the antiderivative of e to the x is e to the x, and the derivative of sine x is cos x. Now let's just see what happens. So we've got e to the power of x times sine x dx is equal to uv. So that would be e to the power of x sine x minus the integral of v du. So that's e to the power of x times cos of x dx. Now that looks very similar to what we started with. So it didn't really get any simpler. Well, let's just try integration by parts again. If it didn't work the first time, let's just try it again. Now, that's the definition of insanity for some people, but let's do it anyways. So we'll make our u cos x this time, and we'll make our dv e to the power of x. That way our antiderivative is still e to the power of x, and the derivative of cos x is negative sine x. Let's put this together and see what we get. So the original question here is e to the power of x times sine x dx, and we don't have to do anything with this first term. And I'll write this in green here to show that that was the second integration by parts that we did. So minus, and then I'll use some brackets. And then it's our uv, so our e to the power of x cos x minus our v du. So our v is e to the power of x. Our du is negative sine x. I'm just going to take that negative and move it in front, and that will actually just cancel this one out here. So I'm left with this in the integrand. And that just is getting worse. I mean, we started off with one thing, then we got one term, now we have two of these, and still an integral here to deal with. But if we look carefully, we actually have done something here. And I'm just going to rewrite this without the brackets, distribute in the negative here. And you can see we ended up with something quite interesting. We ended up with the integral that we started with, which is pretty funny, but it actually lets us do something crazy. How about if we've got this and this and they're the same, well, let's put them together. And then it won't be on this side and we won't have to deal with it. So add it to both sides, and that gets rid of it here. And on the left side here, we just have two of them. There. And that helps us because all we're left with on this side are these two terms here, and we don't need to integrate them. So you might say, well, yeah, but that's not the original question because there's a 2 in front, and you're right. So all we have to do is divide both sides by 2 to move it back onto the right side. So e to the x sine x minus e to the x cos x divided by 2. And we need a plus c because it's an indefinite integral. Now you might be thinking that it was just crazy coincidence that I threw in the right u and dv, or that I knew what to do in the first place. Well, a fun thing to do would be to try this question by switching the u and dv in this first integration by parts and see if you can make it work. And you should find that it will in fact work. So when you pick your u and dv in this question, either one will eventually get you to the right answer. As long as you do the same thing in the second one, it'll work. So trig and exponents are generally interchangeable. Neither one really simplifies, as you can see here, and so either one will probably work. If you go back and look at this one, making logs your u is probably a good choice. And this one here, making something algebraic like a polynomial as your u would definitely be your preference ahead of a trig. But there's always exceptions to those rules, so don't be afraid to just try something, and if it's not working, go back and try a different option. Here's an example where we've got three things. We've got a linear, we've got an exponential, and we've got a quadratic. So we just bundle two of them together and make them our u or our dv. So in this question, we need to bundle two of these together and make it our u. So let's just try x e to the power of x as our u, because the derivative of that isn't too bad. And we'll make this our dv. So 1 over x plus 1 squared, because when I take the antiderivative, I'm going to get rid of this squared here. That'll probably be a good thing. So the antiderivative of this would be negative 1 over x plus 1. The derivative of this one we'll need the product rule for, so the derivative of x is 1, leave this one alone, plus, leave this one alone, derivative of this is, well, e to the x. Okay, so that looks pretty nice, except we do have e to the x and e to the x. So we can factor that out, e to the x. We can factor it out now or later. This will be 1 plus x. Now, we need our uv, so that's negative x e to the x over x plus 1 minus the integral of v du. So we put all this in here, and it's just looking like an awful mess, but take this negative, cancel that one. But you see something cool here is that the x plus 1 and the 1 plus x here, they can cancel. And that really simplifies our integral here, making it possible. Leave this messy first term alone, and the antiderivative of e to the x is e to the x, and we need a plus c for our indefinite integral. You should be able to integrate by parts. Here's some questions from the textbook. Give them a try. See if you know what you're doing.